So you may have heard of absolute value before, and essentially what it just means is we're getting rid of the negatives. We're focusing on the magnitude or the distance of a function. Okay, so this is the overall definition, and the notation is that we use these sort of just straight vertical lines, and basically we're trying to get rid of negatives in an absolute value function, right? When it's total absolute value, we don't care about whether it's positive or negative. We just want the number by itself. And that's sort of where this definition stems from, is that the absolute value of x is a piecewise function. And that basically just means that it's just equal to x if x is greater than 0, or it's equal to negative x if x is less than 0. Now, what that means is, let's say if x is 4, right? Let's say we're looking at the number 4 here. Well, the absolute value of 4 is just 4, okay? Right? Because there's no negatives involved. So if there's no negatives involved, then there's not really anything to it. But let's say we're looking at negative 4, and we're looking at the absolute value of negative 4. Now, using this definition, since x is less than 0, the absolute value of x is equal to negative x. So we're basically, this absolute value of negative 4 is going to be equal to minus or negative and then negative 4, which in turn also gives you positive 4. And that's basically the overall definition of absolute value. So if we're going to apply that to some questions here, so some simple questions here. If we look at the first one, we've got the absolute value of 14 minus 7. So the way to do these questions is you just fill out or you just solve whatever's inside of these absolute value first as you normally would. And then we'll look at that absolute value definition, whether the answer actually changes. So if we look at the first one, we just do 14 minus 7, which gives us 7. And therefore the absolute value of 7 is just 7. The second one, minus 3 minus 5 is equal to negative 8, which the absolute value of negative 8 is going to be 8. Remember, we're just getting rid of those negatives. And then the third one, we've got 11 minus 14, and then we've got minus 5 at the end. So we take the absolute value of negative 3, which is just 3, and then we also have the negative 5 at the end. So 3 minus 5 gives us negative 2. Now a bit more of the algebraic questions. If we look at these ones, we're basically sort of using that same sort of rule. So if we have the absolute value of 6x plus 4 is equal to 8, 6x plus 4, this can be either a positive, this can either be like positive 8 or it can be negative 8, right? Remember, that's because positive 8 or absolute value of 8 is equal to 8 and absolute value of negative 8 is equal to 8. So that's what we're sort of looking at here. So we can have either, the positive absolute value is equal to 8, or we're looking at the negative version as well. And that's why we're usually going to have two solutions. So we solve for both those. 6x plus 4 is equal to 8. We get x is equal to 2 over 3. Whereas if you have negative bracket 6x plus 4 is equal to 8, that means that 6x plus 4 is equal to negative 8, which gives us x is equal to negative 2. So we have two solutions in this case. We do the same thing for b. However, since we're going to have it equal to 0, we can't have two solutions, right? Because the absolute value of 0, you can't have like a positive 0 and a negative 0, right? There's only one 0. So for that reason, the solution for that is just going to be x is equal to 2. Okay? Even though we've tried doing it using both solutions, we're still going to get 2. The answer, x is equal to 2 for both of them. Now, this question is a bit more trickier because we've got absolute value on both sides of the equation, right? We've got absolute value on the left-hand side, and we've got absolute value on the right-hand side. Now, we're going to use this hint here, and it says that for any algebraic expression u and v, if you have absolute value of u is equal to absolute value of v, then again, we have two sort of situations. U can equal v, or u equals to negative. So we're going to use that hint, and we've sort of used that in the saying that 5x minus 1 is equal to 2x plus 3, or 5x minus 1 is equal to negative 2x plus 3. Okay? And it's really important to have that negative outside, and everything was in brackets. Sometimes students make the mistake of just applying the negative to the first term, so negative 2x, and then they just leave the 3 at the end. So that's incorrect, right? You need to make sure we have that bracket there, and we're applying it to both terms. Then we just use our algebra there, and we get x is equal to 4 over 3, or x is equal to negative 2 over 7. Okay, so nothing really too complex about absolute values. Essentially, we're just sort of looking at the distance or the magnitude. We'll have a look at how to graph these sort of equations in the future as well. But this was sort of just an algebraic introductory lesson on that.